Can you see the screen?
Yes.
So, so for Papia, what you need to do is you need to go through this. And the recordings are also there. Recordings for the classes also. So please go through the notes, and then if you have any problem, kindly tell me. Okay? We are almost in the middle of this chapter. So the first chapter, that is atomic structure. What we are studying is the de Broglie equation. That is de Broglie equation. Then in the de Broglie equation, we have learned it is not like there will be only particle nature or only wave. So it says that light, as we know, light can have both the wave nature as well as the particle. That means from electromagnetic spectra that you have, here we are seeing that light is a wave. Whereas when we studied in lower classes about reflection, diffraction, there we had actually considered light to be a particle. So light can have both wave nature as well as particle nature. So both this nature, wave and particle, both the nature, both the form exist simultaneously in the light. It is not like no such on-off mechanism is there. There is no such switch to wants to tell it that now you behave as a wave or you behave as a particle. Both the nature are simultaneously existing. So de Broglie said that then this can happen for electron also, and for electron can also exist as a particle as well as a wave. So that is when we say that both particle and wave nature exist simultaneously in the subatomic particles. Then what we learn? Then we learn that okay, fine, you are saying that electron is also behaving like a particle. What is the wavelength? For calculating the wavelength, de Broglie made is de Broglie, which is a very simple proof. That is E is equal to mc squared, which is the Einstein's equation, and E is equal to h nu. So he just equated the E equal to mc squared and E is equal to h nu, and we got mc squared equal to h nu. Now h nu can be written as hc by lambda. This can be done. We did this one, and we got that mc is equal to h by lambda. So lambda you get is equal to h by mc. Now electrons are not moving with the speed of light. So he just replaced the c, that is the velocity of light, with v, that is the velocity of light. So the final formula is lambda is equal to h by mv. So that means the de Broglie's equation becomes lambda is equal to h by mv. Now what is h? H is known as the Planck's constant. And what is mv? This to have learned in physics. Mv is the momentum. So lambda is equal to Planck's constant by moment. And this lambda is called the de Broglie wavelength. So this is the formula that de Broglie gave. And it was seen that the wavelength was measurable. The wavelength that we got using this formula was observed that we can easily measure the wavelength. That means obviously de Broglie's theory is correct. This is the de Broglie's equation that we had done in the previous. We have ended our class with this. So now we will do further more with the de Broglie and then later move on to the Heisenberg's principle. Let's take a question. Question kind of or any. Suppose we are saying fine. electron has a de Broglie wavelength. How to calculate it? So let's calculate that one. Calculation of de Broglie wavelength. And no need to write these things now. Now you just listen to what I am saying. After the end of the class, I will send the PDF to your sir and he will forward the entire PDF. I don't think there's any even. Now you just listen to the story. Calculation of de Broglie wavelength using de Broglie equation. For an electron. Of hydrogen. Let's see. So what is the formula? They have asked us to calculate the de Broglie wavelength. So what will be the formula that we use? This formula only. Lambda is equal to h by mv. Lambda equal to h by m. Now what is the value of h? H is the Planck's constant. Come on. Tell me what is the value of h? What will be the value of h? Tell me.
6.6 into 10 to the power 37 joule per second.
It's not correct. 6.6 into 10 to the power of minus 34 and not 34. Minus 34. The value of Planck's constant Joule second. Now what is the mass of electron? What are you doing? We are doing for an electron. So what is the mass of the electron? This was done in the first class. Mass of electron 9.1 into 10 to the power of minus 31 kg. And what is the velocity? Velocity is 2.3 10 to the power of 6 meter per second. All the data were done. Where was the velocity done? The velocity was done over here. See, they had done it. 2.3 into 10 to the power of 8 centimeter per second. That means this will be 2.3 into 10 to the power of 6 meter per second. Apia, kindly see the notes, okay? Otherwise, we'll find it a bit difficult without slicing the notes.
Okay, sir.
Suddenly, you were seeing all these. Lambda is equal to, and if you have any doubt, always tell me because it's like a very, very basic chapter. So, if your concepts are not cleared for this chapter, then it will effect on the other chapter. 6.6 into 10 to the power of minus 34 divided by what is the mass? 9.1 into 10 to the power of minus 31 into 2.3 10 to the power of. So if you do the calculation, what will you get? You will get 3.16 into 10 to the power of minus 10 meters. And 10 to the power of minus 10 is only called the angstrom. 3.16 angstrom. So we are getting a as the answer. This is the wavelength. This is the wavelength, 3.16 angstrom. So what we can say is that we are actually getting a measurable value of the wavelength. That means the the value of the de Broglie wavelength that we are getting can be easily measured. And since we can easily practically measure it, that means obviously the de Broglie wavelength exists. It is not just some random theory that de Broglie made up. Obviously, the de Broglie wavelength has to exist. So that only I will write. The value of the wavelength, the value of wavelength, the value of wavelength can falls in the X-ray region. Falls in the X-ray region. Hence, experimentally measured and believable. Since we can measure it, that means there is no problem to believe the theory also. Because we have seen that we can measure it, that means it is proof. Otherwise, you might think that de Broglie just made up a random theory. Because first of all, the theory is like a very revolutionary theory that both particle and wave is acting simultaneously. It is difficult to believe. So still our concept was either it is a particle or it is a wave. And de Broglie is saying that no, both is actually existing simultaneously. It is difficult to believe. But here we can see that since it has been measured, that means obviously theory can be verified. So now over here I have taken this 10 to the power minus 10 meter to be as angstrom. That means I have converted the meter to angstrom. Did you know this conversion before? Meter to angstrom conversion or nanometer to meter conversion? Do you know the conversion factors or should I write it down? Let me write it down only. Suppose this 1 millimeter is equal to how many meter? Tell me. 1 millimeter মানে কত meter? How many meter is it? Tell loudly, I can't hear you.
100.
Why 100? Tell me 1 meter is equal to how many millimeter?
Just a meter.
1 meter is equal to how many millimeter?
100, sir.
Not 100. 1 millimeter. 1 meter is equal to 1000
1000.
1000 millimeter. So then 1 millimeter is equal to how much? So that means we can say 1000. Yes, 1 by 1000. 1000 millimeter is equal to 1. Therefore, 1 millimeter is equal to unitary method 1 by 1000. That means this is going to be 1 by 1000 মানে কত? 10 to the power of minus 3. Because 1000 is 10 to the power of 3. So if you put this above in the numerator, then this will become 10 to the power of minus 3. So 1 millimeter equal to 10 to the power of minus 1 millimeter equal to 10 to the power of minus 3. And what is 1 micrometer? 1 micrometer. 1 micrometer. 1 micrometer. This mu is called micrometer. micrometer. This is equal to 10 to the power of minus 6 meter. 10 to the power of minus 1 nanometer. 1 nm per nanometer. All this nanotechnology that we have is coming from the word nanometer. Okay, because the nanotechnology, the length of the components of a thing, nanometer range. That is why nanotechnology. This is 10 to the power of minus 9. 1 angstrom. Angstrom is a, but there you have a degree like this, called angstrom. 1 angstrom is equal to 10 to the power of minus 10 1 pm, 1 picometer. 10 to the power of minus 12 meter, 1 FM, femto or fermimeter. That is equal to 10 to the power of minus 15 meter. As you can see, it is increasing by 3, minus 3, minus 6, minus 9, minus 12, minus 15, like this way. Only angstrom is a bit different, that is 10 to the power of minus 10. These are the conversion factors. Now you need to remember this conversion factor as it will be helpful both in physics as well as for chemistry. And particularly for chemistry, because in chemistry we are dealing with all those small objects. So that's why small object means small data. That is why this. So that's it. So remember the conversion factor. And then let's move on to the next one. So here we can see that we have seen in the example 3.16 angstrom. Here we can easily apply the de Broglie wavelength for hydrogen atom. So now what if anyone says, okay, this I understand that hydrogen atom can have de Broglie wavelength. But what about our daily objects, the objects that we see around us? What about them? Do they also have the do they also have your what, de Broglie equation? Does that even the daily life objects that we have around us, do they also follow the de Broglie equation? So this is the next point of discussion will be application of application of de Broglie application of de Broglie to macroscopic particles. Macroscopic particle. That means our daily life object with a big inside. So let's see this one. So let's take we are considering a ball. We are considering a small ball. Suppose a small object. The mass of the object is 5 gram. Mass of object and the velocity of the object is 10 centimeter per second. Come on, you will only do it. That what will be the value of lambda? What will be the de Broglie wavelength? What will be the value of lambda? Just put the values in the de Broglie equation and get your answer. So what will be the de Broglie wavelength in this case? And H, so as we have done in the previous one, 6.6 10 to the power of minus 34 joule second. So do the math, do the calculation and tell me what are you going to get the value of de Broglie wavelength? I'll be giving like 2 minutes time to do. Okay, so yes, did you get the answer?
Sir, it will be 1.32 into 10 to the power minus 35.
Yes, 1.32 into 10 to the power of minus. So that means lambda is equal to h by mv. Only the one formula is there. Lambda is equal to h by m. So what is h? H is 6.6 into 10 to the power of minus 34 divided by m. What is m? 5. What is velocity? 10. So this is going to be 6.6 divided by 5. What will be the answer? 1.16. That means 3. Okay. And this 10 will also go in the numerator. That means 10 to the power of minus 1. Or I will get 10 to the power of minus 35 meter. Yes, correct. The answer is correct. Total of meter it's in centimeter. So over here you can see that the value of the wavelength is so small. You see 10 to the power of minus 35. That means 0.30, then you are writing 32. So that means the value is so small that it cannot actually be measured because it is so small a value that cannot be measured. Yes, mathematically we are getting a value. Mathematics will always give us a value. For example, where does parallel lines meet? Suppose if we have two parallel lines, then according to parallel line, according to mathematics, where will these two lines meet? Yes. According to mathematics, these two lines will meet at infinity. Mathematics is giving an answer to this one also. But you see, naturally, we cannot go to infinity. Infinity is, think to infinity is not possible. The moment you think that you have reached infinity, actually the point goes further from. So that means the physical significance is that these two lines never meet each other. But according to mathematics, it is still giving an answer that the line meets at infinity. So here also, mathematics is giving us an answer. That is, the value of wavelength is 10 to the power minus 10 But in reality, the value is so small that it cannot actually be measured. So we will write this one only, that the value of wavelength, the value of wavelength, the value of wavelength, the value of wavelength is so small that it cannot be measured. That it cannot be practically measured. thus we can say that de Broglie equation cannot be applied to our macroscopic means daily life big objects. So de Broglie equation cannot be applied, but is not applicable for macroscopic part. It is applicable only for microscopic part. I hope it is clear to everyone. Yes or no?
Yes, sir.
Apia, is it clear? Like, are you
Yes,
getting the
sir.
approach of the sum?
Yes.
So this is what. So that means de Broglie equation is only applicable to the subatomic particles like electron, proton, all those small objects, not in our day-to-day big objects. And thank God it is not applicable. And basically you would have seen a truck moving like a particle also in a straight line as well as moving like a wave. So then the next topic of discussion will be the relation between relation between relation between kinetic energy of an electron, kinetic energy of an electron, and its de Broglie wave. And its de Broglie wavelength and its de Broglie wavelength. The relationship between the kinetic energy of an electron and its de Broglie wavelength. Try to do the derivation. Try to do the derivation. Think how you can get to kinetic energy from using the by using the de Broglie equation. Think what is the de Broglie equation?
Lambda equals to h by mv.
Lambda is equal to h by mv. And for kinetic energy, what is our target? I need to find out half mv square from half mv. Yes, so now let us modify the equation. So let's square both the sides. We get lambda square, squaring both sides, squaring both sides. We are getting lambda square is equal to h square by m square into v square. This is what we get. We have already achieved our target of v square. We have found out v square from here. So let's bring it to the left hand side. M square v square, that is equal to h square divided by lambda square. So now let us write mv square from mv square, that is equal to h square, and one m is brought from the left to the right hand side. So m into lambda square, m into lambda square, or half mv square. We are multiplying both sides by half. Half mv square, that is equal to h square by m lambda square. And what is half mv square? Half mv square is only kinetic energy that you have learned from lower class physics. Kinetic energy equal to h square lambda square plus. Got our proof. Now, if someone asks you to find out the lambda from here, the question is telling you to find out lambda from here, then how to do it? So, from this equation, now we make lambda as the subject of equation. That means it can be written that 2m lambda square, m lambda square, that is equal to h square by kinetic energy Ke. So, or you can write that lambda square equal to h square by m Ke. Therefore, lambda equal to cover of h square m Ke. So you can write h by, because numerator can be removed of the root over, h by cover of kinetic energy. So this can also be written as the relation between lambda and kinetic energy. In one equation, kinetic energy is the subject of the equation, and in another equation, lambda is the subject of. So this is just simple mathematical formula derivation. It's not chemistry, just playing with it. Just rearranging the equation so that we get to our required value. So is the derivation clear to everyone?
Yes, sir.
About the others, is the derivation clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now let us do another sum using this particular form. Question kind of. And this you have to try. That it says an electron and proton, an electron and proton have same kinetic energy. Have same kinetic energy. They have the same kinetic energy. Which one will have higher de Broglie wave? Which one will have higher de Broglie wave? Higher. of wavelength. When electron and proton have same kinetic energy, which one is going to have a higher d probability? Let me say you one information. That is, the mass of proton. Also, you know this. This will not be told generally if the question comes. I'm telling you for the sake of simplicity. Mass of proton greater than the mass of electron. The mass of proton is much greater than the mass of electron. Tell me to the answer. Take 2 minutes time again. Simple, just putting it in formula. And if you need to see the formula, then I'm writing the formula also there. Lambda is equal to h by over of nk. Bring the sum. Answer. So let me do it.
Sir, electron has higher wavelength.
Electron has higher
Higher
wavelength.
wavelength.
Yes, electron has higher wavelength. Correct. Let's use instead of using all the this so because it is same kinetic energy same. So let us even if you do with that one also the same thing will happen. So what is the formula? That is kinetic energy that is equal to h square by lambda square. Now see, since you are doing it for electron, let's mark it like kinetic energy of electron that is equal to h square by 2m mass of electron into the wavelength of it. We are just marking them up. And similarly, kinetic energy that is equal to h square divided by lambda square. So this is for proton. So let's mark it. The proton, mass of proton, the wavelength of the proton. We have just marked them. Mark the electrons and protons so as not to confuse. Now, according to the question, what does the problem say? According to the problem, kinetic energy of electron, it is said that they have the same kinetic energy. That means this value of kinetic energy equal to the kinetic energy of proton. values must be same. Let's what we get from here. Write h square divided by lambda e square. That is equal to h square lambda p square. H and h will cancel out on both sides. 2 will also cancel out. 2 will also cancel out. And they are in the denominator, so let's bring them up in the numerator. If 1 by a is equal to 1 by b, that means a is equal to b. So here also we are applying this concept to. So mass of electron into the lambda of electron at whole square, that is equal to mass of proton into the lambda of proton at whole square. Now let's make lambda as the subject of equation. Lambda t square by lambda p square for proton, that is equal to the mass of proton divided by the mass of electron. You can write the lambda of electron divided by the lambda of proton, that is equal to root over of mass of proton divided by the mass of electron. Now what did I say? Proton is much heavier than that of the electron. So that means whatever we get, whatever be the value, this will always be a positive value because proton is in the numerator and it is much greater than the mass of electron. That's why it is a positive value, and will come around 2 point something, 3 point something like this for anything. So that means greater than 0, greater than 1. This value will always be greater than 1. 10, 20, 50, 60, whatever. But yes, it will always be greater than 1. So that means it can be said that the lambda of electron also much greater than lambda of proton. Okay, because the mass of proton is greater than the mass of electron. So that's why the opposite inequality will happen where the lambda of electron is much greater than the lambda of proton. So this is the numerical result of the question. So as you can see that it is very less of chemistry and more of playing with equation, rearranging the equation that is in mathematics. Please have a strong concept on mathematics. Maths you are having like offline classes only, right?
Sir?
Mathematics you are having offline classes or is that is also happening online for now?
Online.
That is also happening. But after a few days you will get offline classes for mathematics. Okay. So this was the question. Now let us see this is all about de Broglie. Now we'll see the next question, next topic, which is the Heisenberg's uncertainty principle. Now this is also a strange principle. Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. So let's see this. First, we write the statement, then I will explain it. And the statement comes in your exam. Okay? For de Broglie and others, we do not have a statement, but this Heisenberg has a law kind of thing that comes. Remember the statements and everything. This is a thought experiment. That means he made up the experiment in his own mind. It's not like that he did experiment. Thought experiment. Let's write down the principle. So the principle says that it is impossible. It is impossible. Possible. Determine the position. Determine the position and and momentum of microscopic particle of a microscopic particle of a microscopic particle simultaneously simultaneously with with equal degree of accuracy. So it is impossible to determine the position and momentum of a microscopic particle simultaneously equal degree of accuracy. And if you are going to do it, you will always get an error in your calculation. And that error will be delta x into delta px. That is greater than h by by 4. This will be the error you want to do that. Calculate it simultaneously. What is delta x over here? Delta x is the uncertainty uncertainty in the determination of position of a particle of position of a particle. Delta px, that is the uncertainty the determination of momentum of a particle. So this is the principle, okay? So if anyone is asking you to write the principle, you obviously need to write the equation also. Do not just write the statement, write the equation, explain the terms also. You have to write the entire thing if your question is asking you to write the principle. This is not only true for chemistry, but for entire science. If you are told to write a law or a principle, and if that law has an equation with it, then you should always write the equation also. Now let us try to understand it in brief. That it is saying that see, till now what did Bohr theory do? Bohr had actually calculated the radius of the orbit. That means he had actually calculated the position of the electron, and as well as Bohr had also calculated the energy. That means Bohr has calculated the momentum of that particular. So Bohr's theory has actually done both the position as well as the momentum. Both of them had been simultaneously calculated. But this Heisenberg theory says that no, this cannot happen. You can never calculate the position and the momentum of a microscopic particle like electron, protons, like this type of particles. You can never calculate their position and their momentum simultaneously, that means at a time, with equal degree of accuracy. That means you cannot do it correctly. You want to calculate them, there will always be errors in the calculation. How accurate you try to be, there will always be errors in your calculation. You go to calculate the position and the momentum of this microscopic particle. And how to get the error? He said, somehow you try to do it. You try to calculate the position and the momentum. The minimum error that will come in your calculation is h by 4 pi. This is the value of the minimum error. It can be even greater than this also. But a minimum error of h by 4 pi will always come in your calculation. Want to determine the position and momentum of this particle simultaneously. So that will see that's why in the Bohr's theory you are getting a drawback also. That Bohr's theory does not follow the Heisenberg uncertainty. So this is the Heisenberg's uncertainty. So we actually cannot determine these positions. So that means from this Heisenberg uncertainty principle, all those concepts of orbit that we had in our lower classes, that this is the nucleus in the center and this is your orbit, the electrons are revolving. This concept of orbits are getting nullified. So once the Heisenberg's principle comes into place, we cannot say where the orbits are. We cannot identify the position of the orbit. This is the main significance of Heisenberg's principle. That once this theory comes into effect, it will not be possible for us to identify the position of where all these orbits are going to be. So that's why we'll be coming to a probability region. That means we can get a guess of where the orbit can be, but we cannot say it directly. Because once we pinpoint the position, there will be error, chances of error. So this is the basic thing about Heisenberg's principle. And what is the delta x and delta px mean? Delta x is the error in the calculation of position. So delta x is the error in the calculation of position. That if you want to calculate the position accurately, an error of delta with x will always come in your mind. Okay. Again, think about the delta px. Delta px is the error in the momentum. Okay, that is the error that you will get while calculating the momentum. Let's take a simple example to understand this thing, because these are quantum physics, so which is a bit. Suppose this is a road. Okay, suppose this is the road, and this is a car moving on the road. and this is the car. Okay. Now, see, when the car is moving, think of a car is moving at a high speed on a road. Now, if you are observing, you see, as long as the car is in motion, as long as the car is in motion, you cannot exactly say its position, because by the time you pinpoint the position, the car has already changed its position because it is already moving now. So if you say the car is here, if you pinpoint that the car is over here, that means by the time you say that the car is over here, the car has slightly moved from its position. It has come to this point because the car is continuously in motion at a high speed. So that is why it is not possible for you to exactly pinpoint it. And since car is a big object, you can at least see it, you can guess it to some extent. But think this electrons. Now the electrons are so small and so fast in its motion that by the time you pinpoint the position, it's already moved from that particular position. So you can never find out the position accurately. So this is for the position. And again you think that okay, but if you want to again calculate the velocity, then the position is being compromised. So what should you do in order to find out the position is you should actually make the cart, bring the cart to a complete stop and then see where it is lying. So in order to get the accurate value of position, what you should do is you should stop the cart and note down its position. But what will be the problem is in that case, that the moment you stop the car, the velocity of the car becomes zero. That means now you cannot find out the velocity with which the car is moving. So this is the problem. So think of a car which is moving at a high speed on a road. If you have to accurately calculate the position, that you cannot. Why can you not do it? Because as the car is moving with a very high velocity, its position is continuously changing. So you cannot pinpoint that particular position. Yes, you can guess the velocity, but you cannot pinpoint that particular position. But see, you have to find out the position accurately. The only way for you to do is to bring the car to a stop and then note down the position. But if you moment to bring the car to a stop, the velocity is becoming zero. That means now you cannot find out the velocity of the car. So this is the problem. That position and velocity, both of these cannot be accurately determined. There will always be chances of error. Now, since car is a macroscopic particle, for them at least we can do something. We can measure the position. But think this for something which is so very small that it can be seen only with a very high power microscope. Over there, this is going to cause a great deal of trouble to find out the position and the momentum at a time. So this is the basic idea of Heisenberg's principle. Is it clear to everyone? Although we will read about Heisenberg's principle in more details in tomorrow's class. There we'll try to understand it more details. We try to understand the Heisenberg's principle. So is this clear to everyone? Yes or no? This charge thing and the principle thing. Is the basic idea clear?
Yes, sir.
So we'll see it in more details tomorrow. That's it. So for tomorrow's class, so Nanika, is it clear?
Yes, sir.
Tomorrow, see, your class will be from 7:45 only, as usual. So 7:45, you join the session, but you wait till 8:15, okay?
Yes, sir.
7:45 to 8:15 you wait. If I do not come by 8:15, then you do not wait for me. You can leave the session, because as I was telling that there is a cyclone forecast over here, and the news is showing that it will hit in the morning only, in the morning hours only. If the weather is not okay, then obviously there won't be current or the internet connectivity. That's why from 7:45, 8:15, you wait for me. If I do not come by that time, you leave. Okay.
Yes, sir.
So then that's
Yes.
it for today. Bye then. And Nainika, kindly go through the notes